Hi, this is Mr. Goma. In this video, we're going to learn how to draw Lewis dot diagrams for molecules. Now, molecules are the structures that non-metal atoms make when they bond together. And Lewis dot diagrams are a great way to show how the non-metal atoms actually fit together. What's bonded to what? And in what shape do these atoms come together? We're going to follow these 4 steps here to draw Lewis dot diagrams for molecules. So let's go right to it with our first example, which is going to be water. So water, of course, has the formula H2O. What do we need to do? Well, the first thing is to draw the Lewis diagram of the central atom in the molecule. Which one is that? Well, it's usually the first atom in the formula. This is a chemical formula, unless the first atom is hydrogen. Well, here the first atom is hydrogen, so we need to draw the Lewis dot diagram for oxygen. How do we draw a Lewis dot diagram? Well, the only other thing you're going to need is the periodic table. And you want to look to the group number, not these charges that I put up here. You may have these on your periodic table, 1 plus, 2 plus, 3 minus, 2 minus, that kind of thing. That's for ionic compounds. You don't want to use those here. Molecular compounds are made by sharing electrons, not by forming ions. What instead you want to look to is the group number. 1, 2, 13, 14, 15, 16, 17. And remember, the ones place of the group number is equal to the number of valence electrons. So oxygen's in group 16, it's going to have 6 valence electrons. So let's draw an oxygen atom, or at least the Lewis diagram of an oxygen atom with 6 valence electrons. You'll notice I am drawing the electrons in a clockwise formation. 4, 5, 6. This is going to be super important because it's going to make sure that I end up with 2 sides of the oxygen atom that have a pair of electrons, 2 sides that have a single electron. Okay, now we need to draw the Lewis diagrams for all the other atoms at the bonding sites for the central atom. Well, what are the bonding sites? Bonding sites are the sides with only a single electron. Why do we need to draw these other atoms here? Well, we'll see why in just a second. All right, but hydrogen, if we look here, hydrogen has 1 single valence electron. It's in group 1. It actually has only 1 electron total. All right, we need to draw 2 hydrogen atoms because it's H2. So 1 atom here and 1 atom here. Okay, so look, now we get to pair up our single electrons on 2 different atoms to make a bond. So here if we look, we'll notice that by pairing up these electrons, we're forming a covalent bond. A covalent bond is a sharing of electrons between 2 different atoms. So we can share this electron on the hydrogen and this electron on the oxygen. We've made a covalent bond there. We can do the same thing over here. And why does that benefit each of these atoms? Well, look, before oxygen only had 6 valence electrons. But when you pair up electrons, you get to count both your own electrons and the electrons in the shared pair. So now oxygen has 2, 4, 6, 8 valence electrons. So it's much more stable. Hydrogen has 2 valence electrons, but remember, in the first row of the periodic table, 2 valence electrons gives you noble gas configuration, so that it's also very stable. All right, so now we're left for the last step here, which is to redraw our diagram, but replacing the 2 dots of the bonding pair with a line. So the line is how chemists show that we have a covalent bond. So 1 covalent bond here, representing this shared pair of electrons, and 1 covalent bond between the oxygen and the hydrogen down here. Don't forget the 2 lone pairs on oxygen. And now we have a good Lewis dot diagram for water. You'll notice that this Lewis dot diagram shows that water has a bent shape, which in fact it does. Okay, so great. So that's water. Let's go on to our next example, which is CBr4. All right, so CBr4. We're going to follow the same process. First things first, drawing the Lewis dot diagram of the central atom in the molecule. Well, that's going to be carbon because it's the first atom in the formula, and we don't have a hydrogen here. So here's carbon. Let's bring out our periodic table to figure out how many valence electrons we should be drawing. Carbon, group 14, so that's going to be 4 valence electrons. Draw them in a clockwise formation. 1, 2, 3, 4. I don't get to double up. All right. So now I get to draw my 4 bromine atoms. And I'm going to want to draw them at these 4 bonding sites for the carbon here. Let's find bromine on the periodic table. and bromine is right here. Lots of folks ask, how on earth, Mr. Goma, can you find these atoms so quickly? Well, part of the reason you should be able to find them a little bit faster, at least for making molecules, is that you're using only a small portion of the periodic table. Remember, only the elements to the right of the staircase are nonmetals, in addition to hydrogen. Hydrogen is the one exception. It's the only element on the left-hand side of the staircase that's a nonmetal. So I'm really only looking right here and thinking that hydrogen's over here. All the rest of these elements are metals, and if you have a metal, you're not making a molecule, you're making an ionic compound. All right, so bromine, as we saw, has 7 valence electrons. So in group 17, 1, 2, 3, 4, 5, 6, 7. And remember, I've got to draw 4 bromines. Let's do the other one on top. 1, 2, 3, 4, 5, 6, 7. We'll do another one on the left. 1, 2, 3, 4, 5, 6, 7. And another one on the bottom. 1, 2, 3, 4, 5, 6, 7. Okay, so now let's pair up our single electrons on 2 different atoms to make a bond. So if we look at this carbon and this bromine, we'll see bromine has 1 single electron here, and carbon has 1 single electron here. So they can make a bond. And notice, that'll make bromine much more satisfied. 2, 4, 6, and now 8. So bromine's octet will be satisfied. And that's going to be true for each of these bromines as we bond their single electron with a single electron on a carbon atom. Here's another one. Here's another one. And here's another one here. Don't worry if how you drew your Lewis diagram, your single electron doesn't end up right next to it. All that matters is that your atom has a single electron on it and the other atom has a single electron that can pair up. Great. We'll also notice that carbon now also satisfies its octet with the 4 bonds. 1, 2, 3, 4. Let's draw our final step here, which is replacing the bonding dots with a line. So we have the bromine bonded to a carbon, bonded to a bromine over here, with a bromine on top, and a bromine on the bottom. Don't forget your lone pairs. So 3 lone pairs on each bromine. That doesn't change. One thing to note is that, for example, down here, this bromine, I've drawn the lone pairs on the top of the BR, but notice that's in the way of the bond. You don't want your lone pair to be in the way of the bond. So just make sure that if you start out with 3 lone pairs, you end up with 3 lone pairs, but don't put them on the same side of the atom as the bond there. So great, we've got a good Lewis dot diagram for the molecule carbon tetrabromide, CBr4 now. If this is making sense, go ahead and start doing some practice problems. I'm going to do one more example here if you want to go through another one. I'm going to have another video on how to do Lewis diagrams with double and triple bonds. So if you feel good, maybe jump to that one or just get some practice problems. All right, last example for this video, which is NHF2. Okay, you may notice in this example, we have 3 different elements, but that's okay. We're going to follow the same process as before when we just had 2 elements in the compound. All right, first things first, the central atom is going to be nitrogen. It's the first one listed. And nitrogen has, again, looking on the nonmetal side of the periodic table, 5 valence electrons. It's in group 15. Let's also take a look at hydrogen. That's in group 1, so 1 valence electron. Fluorine, group 17, 7 valence electrons. So 5 for nitrogen, 1, 2, 3, 4, 5. Remember, hydrogen just had 1 valence electron, and there's 1 hydrogen atom. I'm going to put the hydrogen atom over here on the left, but you could put it anywhere. It doesn't matter. 2 fluorine atoms that we have to draw. We'll draw them at these 2 bonding sites here. Remember, fluorine had 7 valence electrons. It's in group 17. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. All right. So let's start pairing up our single electrons to make a bond. Well, one here. So the hydrogen can bond with the nitrogen on the left here. There we go. And going here. So you'll notice nitrogen started out with 3 single electrons and now it's able to make 3 bonds. And when it makes those 3 bonds, it'll have 2, 4, 6 electrons in the shared pairs plus 2 electrons in the lone pair. So that'll be 8. So nitrogen's octet will be satisfied. And so will all the other atoms as well. All right, so let's do our final step, redrawing, replacing the 2 dots with a line to represent a covalent bond. H bonded to N with a fluorine at the bottom and a fluorine on the right. Now let's put in our lone pairs, 2 on top of the nitrogen. 3 lone pairs are on the fluorine. I'll just redistribute them so that they're on the left, on the bottom, and on the right. And again, 3 lone pairs around this fluorine as well. And if you look, you'll notice 2, 4, 6, 8, 2, 4, 6, 8,